All right, welcome to this new UnConference from Cryptoeconomics Hub. Today, we wanted to talk about a specific project, Filecoin, which main purpose is to store in a decentralized fashion every type of data that you can imagine. And for that, not only do they need a specific infrastructure of storage, but also a way to incentivize different types of user to join the system, the network, and behave in a specific way to support the system itself in a specific way. And to go across the project, we have the pleasure to have Nikhil here as a moderator for this session. So Nikhil, when you feel like it, please go ahead.
Right. Thank you, Laurent and Sandra. Thank you all for joining. This is a session we're going to focus on the Filecoin white paper. And we're going to talk about the mechanisms that they have put in place in order to build this decentralized storage network. Before going too much into depth, let's quickly just put a few terms in place, right? So Filecoin is a decentralized storage network, or a DSN, and a decentralized storage network is defined as a system where files are distributed over multiple nodes in a network in a redundant, fail-safe manner, and the files are made available to people by the nodes that or the networks that are nearest to them, again in a redundant, fail-safe manner. So when you contrast this with your traditional HTTP file storage, you don't have a single server or a single source of truth for the file. It's spread out, and the data is transmitted over P2P protocols. Okay, so Filecoin essentially is built on top of what is known as the Ipfs protocol. The Ipfs is interplanetary file system. So this was a P2P file sharing protocol that was introduced by a person called Juan Benet. He introduced it sometime back in around 2013, 2014, and basically it's available today. You can download it on your machines, on your Mac or your Windows. They have builds for it. You can run an Ipfs client and you can share files using Ipfs. So Filecoin is conceived as a system that is as a layer on top of Ipfs, primarily to bring in, like Laurent was talking about, the appropriate incentives so that the decentralized storage network becomes reliable and more importantly a permanent store of data that can be relied upon and which has the performance required to function in the real world, right? So it's a very straightforward idea. The Filecoin is a DSN that is auditable. It is publicly verifiable. Clients pay a network of miners for data storage, and miners offer disk space and bandwidth in exchange for payments, and the miners receive their payments only if the network can audit that their service was correctly provided. Okay, so the first thing to understand, yeah, go ahead.
Before you go into the details of the project itself, I'd like to ask you if you could stretch out the reasons of why a simple, if you will, infrastructure like Ipfs is not enough to scale the way they wanted the project to scale, and why do you need, in this case, a coin, a token, to handle these incentive systems?
So that's a great question, Laurent. So if you go into that aspect of it, so if you step back and think about IPFS, in fact, if you think about P2P file sharing systems, right? You traditionally, the file sharing systems are not new. P2P file sharing systems have been around since the turn of the century. You had Kazaa, you had LimeWire, you had eDonkey. And right now, even now, there's BitTorrent. So that the concept of using a decentralized network to share files is not a new one. But and IPFS goes down the same path as well. But why would we? But the question to think about is, why would anybody want to use a P2P file system? Uh, the answer is basically in especially in the case of BitTorrent and Kazaa and all those things. It was basically because a swarm of it made file sharing files, very large files, much easier and much faster, because you did not have to connect to one machine and be tied to the network or bandwidth requirement limitations of that machine. You could actually take different pieces of files, pieces of the same file, and download them in parallel, right? So that increased your speed and efficiency and all that. So, okay, so if you turn that around and you ask them, okay, then why, if that is such a great system, why isn't that more prevalent, right? Why isn't everybody using BitTorrent and everybody using Kazaa or any of these systems? And the main reason is that there is no the way these systems work is that in addition to providing you with the files that you require, they actually work off the principle that you would also provide some storage from your computer and donate that for use by others. So you would actually host files in addition to downloading the files. So obviously, this means that, okay, hosting files means that you would have bandwidth costs, you would have storage costs, you leave your computer on, so there is CPU and electricity costs, and none of this is actually compensated, right? So in order for you to participate in the network, to be a good member of the network or a valuable member of the network, you would have to be this altruistic person who provides their storage and bandwidth and CPU for free. And the return that you get is possibly that some file that you wanted, you would be able to download a little faster, right? Now, that works as long as there are files that you're interested in that you want to download, right? And so then you would be more inclined to make that particular trade-off and say, okay, yeah, okay, I'll provide my storage because I want to see, I have this particular file, this requirement for these files, and these files are available, and you can get them. But what happens if you don't have a file, right? If you don't have a need to download any files from the network, right? So in that particular case, you would want to switch off or shut down that computer or switch off that particular application, in which case a node comes off the network, and as a whole, the network suffers. So there needs to be an incentive for people to actually provide that particular service, right? They need to provide the storage, they need to provide the network, and all that. More compelling than, okay, the promise that if there is some file that you require or you are interested in, you would be able to download it faster from this particular network. And again, that's not a guarantee, right? It's possible that there may be some big file that you really want, but nobody else in the network is interested in, or nobody else in the network has. In which case, that particular, you're still stuck with the old way of getting the file directly from somebody. You cannot actually leverage the network. So so this particular tragedy of commons, so to speak. So like it's essentially only the popular files are available on the network, and only people who are interested in the popular files would participate in the network. Makes makes the case for creating a cryptoeconomic system, an incentive system to make sure that, okay, this can be used in a more general manner than just sharing popular files.
I see.
So does that make sense?
Yeah. Yes, absolutely. So I guess we could say that they've learned from the experience through IPFS that in order to have a more, maybe not resilient, but a more to have more performance with the file storage system architecture, they needed a way to increase the incentives for every possible files to be available at all times, right? So this is really about making the system more professional, and for that reason, they needed a set of incentives to compensate the effort or the investment that the nodes will do.
Right. So again, see, right now, even now with IPFS, you might the larger audience basically is hobbyists and individuals who want to share files, and they set it up on their machines. There are if you want to attract professional companies and have somebody actually run this as a business, you need to provide a financial incentive for them to be able to sustain that. So yeah, you need to build that, and that's basically the idea behind Filecoin. The idea that, okay, how do we actually get the Amazon S3s of the world and the competitors to the Amazon S3s of the world to use IPFS and be basically compensated for the effort and investments that they do. Okay, so to quickly to move on, essentially, so if you look at Filecoin from a large higher perspective, you have the decentralized storage network. There's also so the unique thing about Filecoin basically is the focus on treating the all the files in the system as one globally addressable file space. So it is not unlike older protocols like BitTorrent. There is no concept of a multiple torrents, and each torrent is kind of an individual set of hashes. This in IPFS, all the data is globally addressable and can be directly pulled from the network, right? So every file that you add is immediately accessible to everybody else in the network. The other big piece to this is the use of verifiable markets. So there are two markets that Filecoin actually uses. One is known as the storage market, and the other one is known as the retrieval market. So from a technical perspective, you could call it, there's a market to service the putting files on the network, and then there's another market that services the getting the files from the network, right? And they are essentially two decentralized exchanges. Okay, so let's talk a little bit about the actors in the system as well. So in the system, you have clients. Clients basically pay to store the data, and they pay to retrieve the data in the DSN via use input and get requests. Then there's the storage miner. The storage miner basically provides data storage to the network, and they participate in Filecoin by offering their disk space and serving put requests, right? And then there are retrieval miners. These miners provide data retrieval to the network, so they actually create an index of the files or the data that they know about and gossip it, and basically commit to providing data, serving data that the users request via GET request. Okay, then there is the network itself. So we can actually personify all the users that run the Filecoin full nodes as an abstract entity known as the network, right? The network basically acts as an intermediary. It runs what they internally call the managed protocol. The network is responsible for giving the block rewards informally when there is a new block in the Filecoin blockchain. They manage they track the available storage. They validate the storage that has been pledged by the storage miners, and audit the proofs that the miners submit to the proofs that they are actually storing the data that they have committed to store. And if they find that, okay, there is a fault, or there is some data corruption, a proof has not been properly submitted, they are responsible. They will then basically try to repair that fault by looking at other miners or other sectors, other pieces of that data, and then trying to create a new contract for them. Okay.
So it really looks like there is a specialization of each type of participant in this global network, right?
Right. So so they have actually what Filecoin has been trying to do is actually kind of keep the storage of data separate as a separate function, and the retrieval of data as a separate function. So they are orthogonal to each other, right? So,
and I guess they expect that the retrieval market will be accessed by many more people than the storage market, right?
Correct. So because of the asymmetry in storage and retrieval, that is one particular reason why they might want to do this. Another particular reason also is because retrieval or gets basically have the market actually is implemented in a slightly different manner, right? So whereas the storage market basically has everything on chain, right? There is a on the blockchain they have a ledger that actually maintains all the deals that are done, and there is all the proofs and the block allocation table that actually maintains, okay, saying that, okay, this piece of data is allocated to this particular block that has been committed by this particular miner. All of that is on chain. So the storage market is more deliberate in that manner. Whereas the retrieval market, for performance reasons, because typically you want to retrieve your file quickly, is actually implemented conceived as a state channel. So it's kind of like a off-chain decentralized market that is set up, and basically there is only final settlements that are done periodically on chain, right? So the chain basically, it's kind of like the closest analogy I could think of is like the Lightning Network on Bitcoin, right? So essentially, a state channel is created, and basically between the client and the retrieval miner, there is a contract that is created and put on chain, and as and when chunks of the file, pieces of the file go down, small micro payments are done until the entire file is received, and then the full payment is committed, and then the channel is closed. So that particular action is done off chain, and also basically retrieval miners are free to actually post or publish their indexes of what piece of data that they have off chain as well, so that they can actually set up their own interfaces to kind of quickly get folks to start interacting and identifying what files that they want and what files are available with them.
Are there any?
Does that make sense?
Yes, absolutely. Another question I would have, if you don't mind me asking questions all the time.
No, please. So I prefer that.
All right. So are there any barriers to entry in each of those two markets? And and is a level of expectation from individuals joining the storage market and individuals joining the retrieval market different in any way?
Well, so when you say there is any expectancy, so I'm assuming that you're talking about a financial commitment, right? So if you look at that, okay. Please, is that am I right, or
yes?
You have another?
So I was more thinking about obviously someone willing to download a file and use it is gonna have to provide to the network maybe less not trust, but
resources.
Yeah, something like that. Than someone uploading a file and making it available to the network itself.
Absolutely. So, I mean, I think I get where you're coming from. So let's look into that a little more closely, right? So how does that particular storage market work? And, we can look into that.
Okay.
Right? So typically, if you look at so the storage market, you have storage miners, right? So how do you become a storage miner? A storage miner basically becomes a storage miner by pledging a certain amount of storage to the network, right? So this is a pledge that is backed by a certain amount of coin, right? So basically what they say is, okay, I've got 1 terabyte of storage that is divided into X number of sectors, and these X sectors I will make available to you for a period of 6 months, and I am pledging this is the amount of coin that I am pledging along with it. So there is a collateral as well, right? So storage miners basically pledge it that way. Once the pledge basically gets onto the onto the blockchain in what is known as the block allocation table, right? So there's a ledger, the block allocation table ledger that is maintained. Once they get that over there, then they can actually start to send out asks, right? What these are receive orders. So they basically can publish saying that I have so much storage space and at this particular price, and it's available for this amount of time, right? And so that's basically from the storage miner side. Now, if I am an individual who wants to submit or add data to the Filecoin network, right? So what Filecoin network requires from me basically is the data that is to be submitted. I submit the data that needs to be stored. I submit the number of replicas that I need of the data, so that it's a configurable value. The more replicas that I have, the more resilient it becomes, because you have multiple copies. And also, the data erasure policy. Once the particular contract gets closed, how do you want the data to be erased? And also, I have to commit a certain amount of the payment coin upfront, right? So I say, okay, fine, I want to store 1 GB file for 1 week, and I want to have 2 copies of it, and here's, I don't know, 10 Filecoin that I'm willing to pay, right? Now that's basically your bid order. And so you have like a maker-taker model where the network basically matches these two. There's a matching, and you basically get matched against the storage provider, the storage miner. And once the storage miner basically,
I have a question.
Sure.
I don't know if you already can you hear me, or is it too loud?
No, I can hear you.
Okay, great. I don't know if you already said this and I missed it, or as it is a market now, and sometimes people have documents that needs to be saved. So If this is not safe, then, you know, like really important documents, how can you be sure that there's always a guarantee that this document will be safe?
Okay, great question. So the short answer basically, the short answer basically is you don't have an absolute guarantee that they will absolutely be safe. All you can do basically is say that, okay, I want to create multiple replicas of this particular document, right? And I can if I'm savvy about it, what the network will basically do is it will actually allocate this particular document to multiple miners. Okay. Now, how do I know that that particular data is still available with the miner? That's basically where the proof of space-time comes in, right? So there is a proofs of storage algorithms that the miners basically have to do. There are two of them. There's one is known as the proof of replication. The other one is proof of space-time. The proof of replication basically is a proof that actually is submitted to prove that a replica of that particular data is mapped to a particular sector on their data on their hard drive at that particular point in time. And the proof of space-time basically is at a very high level. What it does is it basically aggregates all of these periodic pledges or periodic proofs of replication into an array, and basically comes out with a hierarchical. It's kind of like it creates a Merkle tree out of it, so that you can easily tell that, okay, with the root, you can tell that, okay, that this particular piece of data is absolutely there with that particular miner for the amount of time specified, right? So that's basically how you can, as a client, you can ensure, you can go to the blockchain and check and ensure that, okay, that your data is still there. Now, if a miner basically does not is not able to prove that that particular file or that particular document is still there with him, the blockchain basically will penalize him with a proportion of his pledge, a collateral, right? So if I had a collateral of for 1 terabyte of 10 Filecoins, and basically this particular document is a 1 GB document, I will be penalized 1,000th of that, I mean, a proportional value of that particular Filecoin, and that particular what do you call it, penalty is then used to try and see if we can actually, the network then tries to see if they can replicate it with another miner. They create a new deal and put up the file to be replicated with another miner, right? And this is where having multiple replicas of the files is useful to you, because then it becomes resilient. So just to quickly get back, go ahead.
So, can you hear me?
Yeah, go ahead.
Okay. So, if a miner can't prove this, he not only do not get the incentive, he also gets penalized.
Penalized, yes.
Do they explain in the white paper why they take such a strong incentive? Because in Bitcoin, for example, in proof of work, you only don't get the incentive. So it's far stronger, like in proof of stake, when you get on top penalized for not being able to prove something.
Right. So see, because it's basically for this, I don't know the reasons. I can speculate on the reasons. Main reasons I say is basically because of the scenario that you talked about. You know, people might be storing important documents, A, and B, because see, if they are the one of the biggest attacks, or one of the main attacks that happen against the Filecoin type or distributed set storage networks, essentially is this idea of inflating your storage space, right? By kind of fudge and say, okay, I've got 10 terabytes when actually I have only one, right? And basically trying to see if there is any way that that you can kind of game the network to get more money, right? So the strong incentive is put in place, to make sure that this particular malicious actors are discouraged, and B, I think ideally you want to have they want to attract miners basically who have set up their infrastructure, who are basically serious about this, right? So they want to basically say that, okay, instead of creating a CPU farm for Bitcoin mining, why don't you create a storage farm for IPFS or Filecoin, right? So that is the reason why they want to actually penalize. And then finally, they also want to make sure that you are actually paying upfront. The client is actually paying upfront for the storage. So when you say, okay, I want to store a file for a week, and I pay for a week, I want to be able to get back my investment, or at least a portion of my investment, if it is actually stored only for 2 days, right? So these, I think, are the main reasons why they actually put in place that penalty clause.
I also think that there is another reason, which is that you will want your file to be available, as you said, for the time you have selected at the beginning. But then, as a miner, you also have to prove that you haven't deleted the file just after the deal was done, right? And so in case the miner does that, then you have to slash the Filecoin he will have put as a collateral in case he misbehaved in this way.
Right. And to add to it, see, in addition to the money that he's getting from the client, right, for storing that particular file, there is also additional money that a storage miner gets. Storage miner basically gets a block reward every time. So basically, okay. So just to step back a little bit, Filecoin has its own blockchain, correct? So obviously, as a blockchain, you need to be able to add blocks to the chain. Sorry, and you need to have a mechanism in order to add this block to the chain. And the way Filecoin is doing that is that they're using these proofs, right? These proofs of state time and these proofs of retrieval, basically as a kind of like a proof of work, right? So what actually happens is in the Filecoin network, all the miners basically get to participate or get to participate in the competition to win the chance of adding a block to the blockchain by basically showcasing or showing how much data they're actually actively storing currently, right? So so if they say that, okay, I have 10 terabytes of data that I am storing for clients currently on Filecoin, that basically is taken, and then they basically look at the whole entire network and say, suppose that is 100 terabytes of storage in the entire network. That particular proportion is basically important because all the sectors in that 100, all the pieces of data in that 100 terabytes of network is become eligible for voting, for being chosen as a what do you call it? As the person who wins the competition to add a blockchain. So it's not exactly proof of work in that you're not solving a cryptographic puzzle, but you're basically trying to make sure that you're trying to basically increase your proportion of storage in the network so that the chances of you becoming the next winner of the block reward is increased, right? So
and so the reward
again,
here is the capability of storing the next megabyte of data, right?
No, not exactly. There is an informal reward. That particular part of it, Filecoin, the white paper is not fully clear about. My understanding is it could be you could get favorably positioned in terms of the deals, or there's also a component of Filecoin also being provided for you. So if any new Filecoin, if they generate Filecoin, some of that Filecoin comes as a block reward for you, right? So it's more than just the loss to the if a storage miner basically acts as a bad actor, they are not only kind of screwing over the client, they are also messing with the network, right? So that's the reason why I feel that okay, there is that penalty over there, so that if they're caught, they basically are punished.
Mm-hmm.
Okay.
Okay.
So we've been talking about storage miners and the clients. So I kind of briefly touched about proof of storage as well. Let's just quickly just jump into retrieval miners also, right? So retrieval miners get data requests from the retrieval market, right? So there is a retrieval market. This market basically is set up as an off-chain market. Essentially, what happens is that the retrieval miners go and identify the data that is available in their immediate vicinity or their that they want to actually serve, and they create bid orders saying that okay, we can give this particular data for this particular price. And retrieval miners, so then the client basically can come to the retrieval miner and say, okay, I want this particular document, and they provide the hash ID of the document, the file ID of the document. The retrieval miner basically is responsible for then going and getting all those pieces together and sending it to the client. Now, again, in this particular this thing, there is a state channel that is set up. So there is a deal that is done when a bid and an ask basically match. The deal basically is added to the blockchain as a state channel. And off-chain, basically, again, for every piece of data that is sent, a micro payment or a fraction of the payment is made. And then when the client can finally confirm that the data is fully received, that they send the final micropayment, and that particular state channel is closed and settled on the blockchain. Okay.
Right.
So the reason that they're doing this is to make sure that okay, I send you the money, but then you send me a corrupted file or a part of a file, then I lose the money, right? So that's the reason why they came up with this particular mechanism.
I have another question. Do you actually also check on the differences to Swarm? Did you?
Well, I haven't looked into Swarm right now, but I have heard that it's quite similar. Again, see, this is actually one of those things where, so Filecoin is trying to, one of the things that they have actually put in their white paper is this concept of bridges. So what people have noticed, right, that in a lot of cases when you're building dApps on Ethereum and you want to actually store significant amounts of data, a lot of the folks are basically turning to IPFS to do that, right? And so the people in Filecoin basically have recognized that as a big use case and have actually put on their white paper part of their roadmap in, bridges to Ethereum and to DEX and Ethereum and to Neo and to Cardano and a multiple of these platforms, distributed computing platforms. So it's kind of they're kind of competing with Swarm right now in kind of building this particular backend for data storage. So I wouldn't be surprised if Swarm basically takes a lot of the ideas from Filecoin, because obviously Filecoin is also trying to become that same thing, right? And they've actually picked up, I mean, a lot of the concepts in Filecoin, like smart contracts, everything also is coming from Ethereum only. So it's kind of like, okay, yeah, I mean, I would basically say that's kind of like a competing product at this point.
Okay, because I had a look into Swarm some time ago, and I remember that the way you could search for content, because the problem is everything is put into hash, right? So in Filecoin as well, right? And as you can't really search for hashes, they use the ENS in Ethereum, so the Ethereum name service, for connecting to words that are actually searchable. So
yeah,
they
so
do the same thing in Filecoin?
Yeah, absolutely. So in fact, so rather than Filecoin, they have it as a level lower than Filecoin. They have something known as IPNS, so Interplanetary Naming System, right? And what they're using is this a naming concept where basically they have, you know, the location of the particular file, which is essentially the host name, the IP address, the host name, and followed by a colon with a hash. And that hash essentially is the hash of the public key of the of the host, along with the network, the location of the location IP address of that particular host, right? So you have a URL naming convention like slash IPFS slash location colon, and then there is a hash basically that identifies that particular the public key, a hash of the public key and the location, followed by another slash, and then followed by the friendly name, so the IPNS name. So the IPNS name basically again is a DNS text entry that is there in the blockchain, the Filecoin blockchain, which actually maps hash IDs to a particular friendly name, right? So this allows basically users to go to the retrieval market, to the retrieval miners, and basically ask for files using their friendly names rather than a hash ID, and they can translate it for you.
Okay, thank you.
So there are a lot of other. So essentially, we talked about storage miners and retrieval miners and the markets. There's also the network itself, right? So okay, yeah. So there is one important portion of this that I missed. That's important. So we talked about how the storage miner gets the. So there's a receive order and there is a deal made between the client who wants to place a document on the network and the storage miner who's offering the data, right? So one of the things that Filecoin does in order to ensure that, you know, storage miners are not kind of inflating their storage numbers and actually not actually saving it properly, or maybe they're deduplicating it or something. what they do is they do what is known as a seal, right? So in this particular case, what happens is that the network basically takes the client document and kind of divides it up into pieces, right? And assigns these pieces to certain sectors. So a storage miner, when he actually pledges storage to the network, the storage is actually divided into certain sectors. These sectors basically map to sectors in the hard drive, right? And the network basically, when they do the deal, they assign each client piece to a particular sector. And then what they do over there is they actually create what is the proof of retrieval, the proof of replication that is done is actually kind of based on a cryptographic hash calculation from that particular combination of the sector and the client's data, piece of data, right? And the seal is basically what is kept on the blockchain as a proof that, okay, this is the area, or this is the place where this particular piece of data is stored. And every time, like during the proof of space time, or every epoch, right? Every time period when the storage miner has to prove that, okay, they have the data with them, they need to use this particular seal as a key for their proof. So it's not possible for them to actually move the file. If they move the file to another sector, or if they move the file somewhere else, that particular proof basically fails. Okay, and that is one of the main mechanisms by which Filecoin kind of ensures that the storage miners are not inflating the amount of or over-reporting the data storage that they're doing, and they're not doing other things like trying to create multiple identities, all which map to the same storage. So I can have multiple storage miners, say, okay, miner A, miner B, but actually map to the same physical drive. All of them report. So all those kind of attacks basically are mitigated using this particular mechanism. Okay. Now, any questions, any thoughts?
I don't know if you have some material left on a technical level. Otherwise, to wrap up the session, maybe I would like to touch upon the cryptoeconomics general layer, if you will, of the infrastructure. But I don't know. Have you still some things to say about Filecoin?
So there is a bunch of stuff around the network guarantee and requirements and but we can get into the Filecoin consensus. Okay, and that's basically this is actually we talked about Filecoin consensus as well, right? This is where basically we talked about how proof of storage is used as a useful work consensus protocol for adding for electing the person who adds the next block. But let's talk incentives, right? So now, basically here, let's look at it from the perspective of a client that wants to store a piece of data, right? When the client wants to store a piece of data, what they can go with the data, and they can go with their requirements for the data, and they can actually look at the public blockchain and basically go and find out, okay, this is typically the data, the prices that are available for that particular data storage, right? And essentially, the price discovery is one of the things that initially Filecoin basically wants to do automatically. They're basically looking at an automatic matching algorithm. They're basically saying that in the roadmap they may turn it into a more sophisticated price discovery mechanism. But right now they want to actually start with something simple so that there's not that much ambiguity in terms of price discovery. But again, so the client basically goes, he submits this to the network basically finds the cheapest, the lowest price, and then matches it, and stores it. And then basically the client can then periodically at any point in time go to the blockchain network, to the Filecoin blockchain, and check to see what is the status of his particular data, right? And make sure that all the pieces of that data are available. And they do that by looking at these proofs. They don't have to actually go and download the file again. The proofs basically guarantee that particular aspect. Now, when you look at the client from a retrieval market side, so I have a particular IPNS URL for a particular file. I go with that URL to a retrieval miner. Retrieval miner basically maintains an index off-chain. I can just go anywhere to a website or wherever and enter that particular URL, and then the retrieval miner basically will then give me a price quote for that. If I agree to the price quote, I can make a deal and get the data. There'll obviously be multiple retrieval miners. You can go to multiple places and check them out and see which one is the best. Now, the incentives for storage essentially is you are incentivized with fees for obviously storing the file itself. You are also incentivized for storage in terms of the more storage that you commit, the higher chance you have to get a block reward when you are when the new block is when a new block is committed to the Filecoin blockchain. From the retrieval miner perspective, again, they can usually see. So the retrieval miner perspective is interesting. So it is not necessary that the retrieval miner be somebody else, right? It is perfectly possible for a storage miner to be also the retrieval miner, right? It's essentially a persona. It's not like it has to be a different role. So in a lot of cases, Filecoin expects that the storage miner basically will have a retrieval miner capability, and they will just participate using in that same market. In terms of attacks on Filecoin, you essentially have two types of attacks. One is basically where you try to inflate your storage space. So you basically claim to be storing more data than you actually are, either by not having that particular data, or or compressing it in some form. This basically is mitigated using the proof of replication mechanism. And the other attack basically can be that you commit to a particular client at a particular time that you would store the file, but then at a later point you do not store it. Or you delete it or do whatever, corrupt it or whatever. And that particular attack is mitigated using the proof of space-time, which is essentially the proof of replication done over multiple epochs. Typically, an epoch is essentially the time period required for creating a new block. Basically, you take the client can basically take that as a guarantee that okay, that particular file existed for that particular period of time in the storage miner's hard drive. The final attack could be a Sybil attack, where you try to create the miner tries to create multiple identities and generate a whole bunch of identities and try to overwhelm the network that way. So in that, basically, Filecoin actually uses a mechanism that existed before in a network called Kademlia DHT. So what happens there is that every time you want to create become a node on the Filecoin network, right, you have to generate a Filecoin, a node ID, right? And this node ID basically is an expensive process that requires you to solve a cryptographic puzzle. And not only that, this particular node ID is what is used for tracking your performance, right? So all the storage that you're committing over the amount of time that you're committing it, all that is, and the block rewards all go to that particular node ID, right? So if you want to create multiple Sybil identities, you have to make it becomes you have to do this expensive crypto puzzle, and B, if you kind of lose out on the longer term rewards of being in the network if you keep changing your file ID every time, your node ID every time. Now, finally, if you try to have multiple identities all pointing to the same data, that wouldn't work, because basically every time a file is every time you take on a file to store, it actually takes a sector ID from your hard drive, right? So essentially, that particular proof will quickly be detected as a duplicate or a conflict, and then you get rejected. So Filecoin has this mechanism where if too many of your data sectors, the sectors in your hard drive, are found to not have valid proofs, it can basically invalidate that particular node and remove it from its network. So again, these are mechanisms that Filecoin uses against these attacks. That kind of gives an overview, I think, of the cryptoeconomic aspects.
Very interesting. Very interesting. Thank you for this overview of the Filecoin system. Maybe something that we can ask ourselves is how Filecoin is going to compete, if you will, with existing system. Now, it's fair to say that if you want to live in the blockchain space, you cannot use certain type of architectures like Amazon AWS. But then that being said, you kind of mentioned a couple of times that this is going to be a professionalized service, and therefore Filecoin people expect investors or actors at least to invest in some equipment to provide that service. And on the other side, normal users are today not very well used to pay for storage, or at least it's, I think, most of the time seen as a hidden cost, right? And in Filecoin, I assume that, like always, the transactions for using the service are going to be apparent. And so how do you see this going forward in terms of scaling and competition between the centralized and non-centralized infrastructure? And going back to the cryptoeconomics, do you think that the incentives setting in place are going to be enough to compensate for the incumbents, if you will, of decentralized infrastructure?
Sure. So that's a great point. So like it is definitely true that storage is quite cheap. In fact, a lot of people think of it as a hidden cost. But it is also true that in today's world, we are increasingly being exposed to larger and larger data sets, right? So if you take the cutting edge work today that is being done in artificial intelligence, in machine learning, in deep neural networks, the main thing over there basically is the amount of data that they can get to process, right? So you're talking about databases or data sets in the several terabytes to petabytes range. So in those particular cases, obviously the the storage of the data is a major problem, and not only that, the retrieval of the data is a major problem, and making sure that the data is reliably available is also a major problem. So if you look at S3, a lot of money comes to Amazon from these kind of use cases, right? In these particular cases, centralized data storage actually is not optimized for for data retrieval here. So if you take your S3 bucket and your typical mechanism of an HTTP call that goes and gets the file, that's fine for small images and small CSS files. But if you want to do a video, or you want to do a lot of large images, it's not a very performant protocol. That is, it's subject to a lot of network slowdowns and bandwidth challenges. And this is where basically P2P shines, right? And IPFS shines. Filecoin would basically kick Amazon's ass. But one thing, again, a major point that you pointed out was that, it costs maybe 10 cents per month to store a gigabyte of data in Amazon, and probably a couple of cents to transfer that file from to and fro from Amazon every month. So that definitely is that kind of low cost is definitely something that I'm not sure initially Filecoin would be able to match. But again, the proof of the pudding is in the eating. If Filecoin can find enough use cases to grow its network large enough, then I am pretty sure that those kind of economies of scale can be achieved. Now, the larger point, and one that I'm actually surprised you guys didn't raise, is the challenge of DRM and intellectual property, right? What is to actually one thing that Amazon S3 and Google Cloud and all of these providers do is they provide central points where data can be, where if you have where a Hollywood director or even an independent film director can go and say that, hey, okay, one of your people are this particular file system, and they are not using my data. I mean, and they have kind of stolen my video, and they're hosting it there. Can you take them down? And it's pretty easy in Amazon to do that. Whereas in IPFS, it's going to be very hard to first even track down where that file is located, because you have it in pieces encrypted over multiple nodes, right? And you have it actually, don't refer to it in terms of its name, you're actually referring to it as a hash, right? So it's rather difficult to kind of track that down and then figure out, okay, this hash is basically mapped into that particular file, therefore that particular hash needs to be removed. Even if they want to be removed, there is no single authority out here. There's no single corporate entity that can basically have that power to remove it, right? So definitely that's going to be a challenge for Filecoin, especially since, if I'm not mistaken, Filecoin has got venture capital, and they're like proper VCs from Silicon Valley, and they have accredited investors as well. So this will definitely be a concern for them. I'd be curious to see how they handle that.
I was actually saving that question for the end. So thank you for highlighting that point. And in fact, I think because Filecoin did their ICO like a year ago or something, right? And
they did it late last year, actually. August, I think. August or September last year. Yeah,
so almost a year. And So at that point, I remember that it was already an issue raised from the community, and it wasn't so regarding the fact that there is a possibility of censorship, but maybe this is something that we actually need. So in order to be reliable as a service, you have to consider the possibility of protecting property rights from different users. So I'm surprised to see that after a year, they haven't come up with a draft, at least for a solution of how to implement such a dispute mechanism resolution or something of the like.
I suspect it's a hard problem to solve. I noticed that it has not been solved by any of the other coins either that are working in this space. I doubt if Swarm also has that. So they'll probably need to come across that at some point. But I guess they're working on it. Is everything I can say. Okay.
Okay. Great. Well, I think we are running out of time already, so I propose to leave it here. Thank you very much, Nikhil, for being on the show today and highlighting the main characteristics of Filecoin as a decentralized storage system.
You're very welcome, Laura.
Also from my side. No, I actually just want to say the same from my side. It was really nice that you gave this overview. Yeah, a little bit of shame that we had no more people joining, but I guess summer is starting here, so maybe people were outside. Yeah, but thank you so much for these explanations.
You're very welcome, Laura and Sandra. You guys have a good rest of the evening, and I'll talk to you next time.
You too.
Thank you.
Bye-bye. Thank you.
Have a great day. Bye.
Bye.